Determine the intervals for which the given function is continuous. We are given f of x equals the quantity 2x minus 3 divided by the square root of the quantity 32x squared minus 50. There are two things we have to consider here. First, the radicand, or the expression 32x squared minus 50, must be non-negative in order for the square root to be real, and also division by 0 is undefined, which indicates the radicand of 32x squared minus 50 must be greater than 0. As long as 32x squared minus 50 is greater than 0, we would not have division by 0, and the outputs of the square root would be real, and therefore the function f of x would be continuous. So now let's work on solving this quadratic inequality. For the first step, we want to solve the related equation, which is 32x squared minus 50 equals 0. Let's begin by factoring out the greatest common factor of 2, which gives us 2 times the quantity 16x squared minus 25 equals 0. From here, notice 16x squared minus 25 is a difference of squares, giving us 2 times the quantity 4x plus 5 times the quantity 4x minus 5 equals 0. The left side is equal to 0 when 4x plus 5 equals 0, or 4x minus 5 equals 0. Solving 4x plus 5 equals 0, we subtract 5 on both sides and then divide both sides by 4, giving us x equals negative 5/4. Or, solving the second equation for x, we add 5 to both sides and then divide by 4, which gives us x equals positive 5/4. These are the values that make 32x squared minus 50 equal to 0. When the left side equals 0, notice the inequality is not satisfied because 0 is not greater than 0, which means we're now going to plot these 2 points on the number line, but we will use open points because these two values do not satisfy the original inequality. So let's just say we have negative 5/4 here. Let's say 0 is here and positive 5/4 is here. Again, we make open points at x equals negative 5/4 and x equals positive 5/4. And now we will select test values in each of the intervals and see whether they satisfy the original inequality. If they do, the entire interval satisfies the inequality, and if the test value doesn't satisfy the inequality, the entire interval does not satisfy the inequality. For the test values on the left, let's use x equals negative 2. In the middle, we'll use x equals 0. On the right, we'll use x equals 2. Now we can sub these x values into the original inequality of 32x squared minus 50 greater than 0, or if we want, we could use the factored form of 32x squared minus 50, which is 2 times the quantity 4x plus 5 times the quantity 4x minus 5 greater than 0. So we'll go ahead and test x equals negative 2 first. When x equals negative 2 on the left, we have 2 times, when x is negative 2, 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. And then for the factor of 4x minus 5, when x equals negative 2, we have 4 times negative 2 minus 5, which is negative 13. A positive times a negative is positive, which is greater than 0, which indicates x equals 2 does satisfy the inequality, and the entire interval is also true, meaning it satisfies the inequality. So we'll go ahead and graph the interval x less than negative 5/4. Again, because x equals negative 2 was true. And now we'll test x equals 0. When x equals 0, we have 2 times 5 times negative 5. Well, a positive times a negative is negative. A negative number is never going to be greater than 0, and therefore the test value is false, and so is the entire interval. We do not graph the interval from negative 5/4 to 5/4 because x equals 0 was false. It did not satisfy the inequality. And now we'll test x equals 2. When x equals 2, we have 2 times 8 plus 5 is 13, times 4 times 2 is 8 minus 5 is 3. The product is positive, which is always greater than 0, which indicates the entire interval is true. So we can go ahead and graph the interval x greater than 5/4. Now we have the graph of the intervals for which f of x would be continuous. Let's also express the intervals using interval notation. Recall on the right we're approaching positive infinity, on the left we're approaching negative infinity, which indicates the given function is continuous over the open interval from negative infinity to negative 5/4, union the open interval from 5/4 to infinity. I hope you found this helpful.